Hello everyone, I am Dr. Jyoti Mandala. Welcome you all to the video lecture series on the course Operating Systems. We are learning different kinds of the CPU scheduling algorithms. So in the last lecture we have learned about FCFS, which is first come first serve scheduling algorithm. I hope you all are clear with that scheduling algorithm. So in today's lecture let us understand how this shortest job first scheduling algorithm will work. Shortest job first, as the name itself it is telling, a process which requires less amount of CPU time will be given the priority first. In FCFS we understood like the process whichever comes first into the ready queue, that will be given the chance. Suppose if 10 processes at a time arrived into the ready queue, all the 10 processes are available in the ready queue. Then if you are adopting FCFS, which then first process will be whichever entered into the ready queue first, that has been given the chance. But in shortest job first, suppose if you have 10 processes available in the ready queue, then the CPU will the CPU will be given to that process which requires less amount of CPU time. I hope you all are understanding. So just make a note of that point. So shortest job first is nothing but the process with less CPU time will be given a chance to be executed by the process. Okay. So SJF selects a process with less burst time. Burst time means you already know burst time is nothing but the amount of CPU time required is referred as a burst time. So SJF selects a process with less burst time and assigns that to CPU for execution. This is what shortest job first. Okay, one important point up here about the shortest job first, you all need to remember, this is a non-preemptive scheduling algorithm. What do you mean by non-preemptive scheduling algorithm? Non-preemptive scheduling algorithm is nothing but once a process has been assigned to CPU, until and unless it finishes its task, the CPU cannot be switched to the another process. So shortest job first is another example of non-preemptive. In our last video we learned about FCFS, which is also a non-preemptive scheduling algorithm, and this shortest job first is also a non-preemptive scheduling algorithm. So to understand this even more better, let us take one example and let us understand how we can calculate the waiting time and the turnaround time using the shortest job first. So let me take one example. Here I have taken one example. So here if you see, I have considered three processes, and all these three processes are having their own required CPU time, which is mentioned in the burst time, which is mentioned in the burst time column. Now observe here one point. There is no arrival time mentioned here. That means let us consider all the processes are arriving at the same time. If that is the scenario, how this shortest job first will work, let us understand. So let us solve this problem first. Now I have one more example also where with the different arrival times, if the processes are arriving at different arrival times, how this shortest job first algorithm will work, that also we will see. But first we will see this one where arrival time is same. Okay, so just make a note of this one. Observe here, I have considered three processes P1, P2, P3. Okay, and P1 requires 4 let us consider seconds. The time is given in the form of seconds. So P1 requires 4 seconds, P2 requires 3 seconds, and P3 requires 5 seconds. So this is the time given. Now what we need to write down, we need to mention three parameters here. Like let me just, the way how we have solved in the last problem. First one is ready queue we need to have, and then we need to have we need to draw a Gantt chart. Okay, and then we need to find out the average turnaround time and the average waiting time. Okay, so what I'll do, let us first draw the Gantt chart, later we will let us fill this table. Okay, so the ready queue and then the Gantt chart. Sorry, yes. Okay. Now, because the arrival time is not mentioned in this problem, so we will be considering the at one time. Okay, at one time, let us consider at time interval of 0, all the process have been arrived into the ready queue. So this is our ready queue. Okay, so in the ready queue, all the 3 processes are arrived. So let us consider P1 has arrived. Okay, P1 has arrived, and P2 is also arrived, and also P3 is also arrived. Okay, okay. Now sorry, which process among these 3 processes has to be considered? If this is a FCFS algorithm, P1 can be considered first, but this is a shortest job first. It will check the burst time of these 3 processes. If you see, P1 requires 4, P2 requires 3, and P3 requires 5. Now of all these 3, if you see, P2 requires less amount of CPU time. So because of that, the P2 has been selected first. So let us draw the Gantt chart. So P2 will be given the chance. Okay, so we have at the 0th second, P2 will be starting its execution first. Okay, so this is 2. Let us consider what I will do. P2 has started its execution. Okay, there's a problem here. 1 second. So 0 seconds, and P2 has started its execution. Alright, now as P2 has started its execution, how much time is required for P2? It requires 3 seconds. So 1, 2, 3 seconds. So 3 seconds P2 will complete its execution. Now we have finished P2. Now we have 2 more processes available, P1 and P3. Between P1 and P3, which process will be selected? We need to check the burst time. So P1 requires 4, P3 requires 5. Whichever requires less amount of time, that is what shortest job first. So that will be selected. As per our example, P2 requires less amount of time. So that will be given the chance. So we will be executing, what is that? P1. So P1 is starting now. P1 is starting its execution. How much time it requires? P1 requires 4. So 3, 4, 5, 6, 7. So up to 7th second, P1, P2 will finish its execution. Now P2 is also, P1 finished its execution. Now only process available is P3. Now P3 will start its execution. How much time is required for P3? As per our Gantt this one problem, P3 requires now 5 seconds. So 7 plus 5, which is equal to 12. So for 12 seconds this will be executed. So this is the Gantt chart. I hope you all are clear how it is working. Right, so P2 is selected first. Why? Because P2 requires less amount of time, and then P1 is selected because between P1 and P3, P1 is having less amount of time, burst time I am talking, and then P3 is given the chance. Now if this is the scenario, now let us find out what is the wait time and what is the turnaround time. Now what I will do, let us have one column where let us find out the waiting time, and also let us find out the turnaround time also. Okay, so wait time and turnaround time, let us calculate. So this is wait time and this is turnaround time. In the last class we learned what is the formula for the wait time. Wait time is equals to start time minus arrival time. Okay, and turnaround time is nothing but completion time minus arrival time. This is what the formula we have learned in the last class, right? So let us apply the same formula. For P1, what is the waiting time? What is the start time? 0. And what is the arrival time? Let us consider the arrival time for this problem which is same, let us consider it is 0 at 0th second, which is common for all the seconds, for all the process. So 0 minus 0, which is 0, and for P2 the start time is 3. 3 minus 0 is 3, right? And then for P3, 7 minus 0 is 7. So what is the average? 10 by 3. This is the average turnaround time. Okay. by 3. Now what is the turnaround time? Turnaround time is nothing but completion time minus arrival time. So first, I think I have done some mistake here. What is that mistake? Yes, I will just go back. P1 is completed at 7 seconds, right? 7 minus 0 is 7. I hope, sorry. P1 at 3 seconds. 3 minus 0 is 3 here. P2 started at 0 seconds, so 0 minus 0 is 0. I just reversed the things, okay? P3, 7 minus 0, 7. Okay, because I have thought this is P1, that is why earlier I wrote wrong, but now it is clear. P1 start time is 3 minus 0, 3. P2 start time is 0 minus 0, and then P3 start time is 7 minus 0 is 7. Now it is clear, the average is 10 by 3. This is the average turnaround time. Sorry, average waiting time. Now what is average turnaround time? Completion time minus arrival time. Now you can see P1, what is the completion time? This is the completion time, right? 7. 7 is the completion time for P1. So 7 minus what do you need to consider? Arrival time. So 7 minus 7 minus 0 is 7. P2, what is the completion time? 3. Okay. And P3, what is the completion time? 12. 12 minus 0, 12. Okay. Now the total is 22 by 3. That is the average turnaround time. 22 by 3. Right. I hope you all are clear. This is how the shortest job first algorithm will work, where the CPU will be given a chance to the process which is requiring less amount of CPU time. This is first example. In this example, we have considered the arrival time as 0. That means all the processes have arrived at the same time. We have considered all the processes have arrived at 0th second. Then if all the processes are available, then one process which is having the least CPU time will be chosen. Now let us take one more example where the processes are arriving at multiple, like different arrival times. In that case, how to solve the problem? Let us see. Okay. So just consider this problem where I have considered 5 processes. Okay. And these 5 processes, I am going to solve this one. Where 5 process P1, P2, P3, P4, P5 are considered, and each process is having its own burst time, that means amount of CPU time required. Observe here the difference, the arrival time is different. In that case, how the problem will be solved, let us understand. Okay, so for this also we need to draw the we need to have a ready queue, and also we need to draw the Gantt chart. Let us find out the average waiting time and average turnaround time. Okay, so just write down ready queue, and then let us have the Gantt chart. So these two let us try to finish first. Now in the ready queue, what we will do, we will start adding the process to the ready queue. So let us consider first, this is the ready queue. Okay, let us consider this is the ready queue, and this is the Gantt chart. If it requires, I will extend this Gantt chart. Gantt chart starts from 0th second. Now first what happens, P1 process will enter, right? P1, which process will enter into the ready queue first? We need to check the arrival time. Always remember, if arrival times are different, we need to check because always the timer starts from 0 seconds only. So, okay, so at 0 seconds we have got our P4 process. So P4 process has been entered into the ready queue. So add that one to your ready queue. Okay, so P4 process has been added into the ready queue. Now as P4 is only now available in the ready queue, we will start executing with the P4. Okay, so start executing with P4. Now P4 we have started executing. How many seconds it requires? It requires 3 seconds. So let us execute for 1 second. Remember, this is non-preemptive. Until and unless P4 finishes execution, CPU will not be released. But at each interval, we need to check whether a new process is arriving or not. Let us consider after executing for 1 second, we need to check the arrival time. Any new process is coming. If a new process is coming, we need to add that one to the ready queue. So P4 executed for 1 second. At 1 second, if you observe here, we got a new process. What is that process? P3. Now P3 should be added to the ready queue, right? Now let us add P3 to the ready queue. Okay, and then we need to continue with our process P4 only. 2 seconds. Okay, so 2 seconds has been executed. Now at second any process is coming? Yes, we have got one process which is arriving. What is that second process? This is P1. Now we need to add P1 to the ready queue. Okay, so let us add P1 to the ready queue. Before that, this. Okay, P1 has been added to the ready queue. Now P2 completed 2 seconds, but P2 requires P4 completed 2 seconds, but P4 requires how many seconds? P4 requires 3 seconds. So we have done 2 seconds and 1 more second it has to execute. So let us add that second also. What is that? It has to be executed for 1 more seconds, 3 seconds. Now P4. Now at third second we need to check any process is arriving. You can see at third second no process is arriving, and P4 also completed 1, 2, 3 seconds. So we need to stop here. Okay, so stop. So P4 has completed its execution, right? So we can remove P4 now. P4 has been selected and it has completed its execution. Now we have two processes available in the ready queue, P3 and P1. If this is an FCFS algorithm, P3 can be selected. But if this is a shortest job first algorithm, so between P3 and P4, we need to select whichever process is requiring less amount of CPU time. You can see here, P3 requires here 8 seconds and P1 requires 6 seconds. So which one is of the shortest time? 6 seconds is the shortest time. So we need to choose P1 only. Okay, of 6 and 8, 6 is less, so P1 has to be selected. So that's why we are selecting P1. So we are selecting P1, that has to be removed from the ready queue and that has to be sent here. What is that? Gantt chart. P1 has to be selected. Now P1 requires 6 seconds. Now when each second we will start executing. We will execute for 1 second, 4 seconds. Any process is arriving? Yes. Process P5 is arriving here. Can you see? At 4th second process P5 is arriving. So then P5 has to be added into our ready queue. Okay, so let us add P5 into our ready queue. That is what, at each second we need to check whether a new process is arriving or not. I hope you all are understanding what I am doing here. Now P1 continues execution because it requires 6 seconds. We have executed for only 1 second. Let us execute for 1 more second, 5 seconds, and we need to check any process has been arriving at 5th second. Yes, P2 is arriving. We need to add P2 to the ready queue. Okay, so P2 is arrived. P2 has been arrived. We need to add that one to our ready queue. Okay. So we need to parallelly check multiple things here. At each second any process is arriving or not. If it is arriving, add it to the ready queue. But we need to continue with the present process which is already there in the Gantt chart. So until and unless it's finished its execution, we should not release the CPU. Alright, I hope you are all understanding. Now P1 is executed for 1-2 seconds, but it requires 6 seconds. Let us continue with thing. What is the thing? 1 more second it will execute. 6th second we can see all the process have been arrived and they are added to the ready queue, and after 5th second no new process is arriving, so no need to check further. Okay, so it will execute for 1 more second, 7 seconds, right? And then how many seconds? So 3 plus 6, what is 3 plus 6? 9. So it will execute for 1 more second, 8, and it will execute for 1 more second, 9. I hope you all are understanding. So up to this process, P1 will execute its task. So 1, 2, 3, 4, 5, 6 seconds. Now P1 has completed its execution. Now which process should be selected among P3, P5 and P2? P1, P4 and P3 completed its execution. We have P3, P5 and P2. So whichever process among P3, P5 and P2 is less, that has to be selected. If you see 2, 8, 4, 2 is less. So we need to select 2 only. Okay, so we will be selecting our second process, that is P2. Alright, so let us start executing with the P2. Now as all the process has arrived, we don't have any new process arriving here. So what we can do, we can continue with our work. P2 requires 2 seconds. So 9 plus 2 is what? 11. So 11 seconds it will execute. Right? So that is what is happening, done. Now P2 is done. Now we have P3 and P5 left. Between P3 and P5, P5 requires less amount of time. So P5 will be selected now for execution. Okay, 4 seconds. So P5 will be selected now for execution. So let us add that one to our Gantt chart. P5. Okay, how many seconds it has to execute? 4 seconds, right? So P11 plus 4, which is equal to 15. So let me represent 15 here. So that is what? That much of time the CPU will be executing P5. Now the only process that is available in the ready queue is P3. So let us select P3. Okay. So P3 only is left. So we will select P3. That is only left. We will select P3 first. And then that has to be added to the Gantt chart. P3. How many seconds? 8 seconds. So 15 plus 8 is 23. What I'll do, I'll just extend this one. Okay, and here the final time 15 plus 8 is 23. So this is the Gantt chart. Now by considering this Gantt chart, we have to write down what is the waiting time and what is the turnaround time. Okay, so let me extend the lines here. So this is the waiting time, let us consider, and this can be the okay, and this can be the turnaround time. Okay, all right, now let us see, this is the waiting time and this is the turnaround time. Now you know the formula. Waiting time formula is equal to, again I am writing the same, start time minus arrival time, and turnaround time formula is completion time minus arrival time. Okay, so let us fill one by one. What is the first one? Process P1. Now P1, when it started at 3 seconds. Did you see here? 3 minus arrival time. What is arrival time? 2. 3 minus 2 is 1. So this one is 1. Got it? Now P2. What is the start time for P2? 9 seconds. Minus arrival time is 5. 9 minus 5 is 4. Okay. And P3. What is P3? Start time is 15 seconds. 15 minus arrival time is 1. So which is equal to 14. Okay. P4. P4 start time is 0. 0 minus 0 is 0. P5. What is the start time? 11. 11 minus 4 is 10. I think somewhere it is wrong. 11 minus 4. 11 minus 4 is what? 7. Got it? So this is about the waiting time. Now what is the average of this one? Average waiting time is total of all these values, which is equals to 1 plus 4 plus 14 plus 8 is equals to 26 by 5. So this is the average waiting time, 26 by 5. Okay. Now let us calculate the turnaround time. What is turnaround time? Completion time minus arrival time. So P1, when it has been completed, P1 completed at, you can see from this Gantt chart, at 9 seconds P1 completed. So 9 minus 2, which is equals to 7. Okay, right? Next, P2 completed at 11 seconds. So 11 minus 4, which is equals to 7. Right? Now P3 completed at 23 seconds. 23 minus 14. 23 minus 1. What is that? 22. 23 is the finish time, completion time, and arrival time is 1. Okay. And P4 is 3 seconds. So 3 minus 0, 3. And P5 completion time is 15. 15 minus 4 is 11. Now you need to calculate the total of these values by 5. So that is your total turnaround time. So this is how we can make use of this shortest job first algorithm to calculate the average waiting time and average turnaround time. Okay, so this is how shortest job first algorithm will work. I hope you all are clear with this algorithm shortest job. Let us all meet in the next lecture. Until then, thank you all of you.